Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 5.3, which is going to deal with interpreting rate of change and slope. Now, before we jump into stuff for today, I just want to make you aware that section 5.3 is the last section of module 5. So, as usual, just know that that means that a quiz is upcoming, and I just want to make you aware of that. So again, Section 5.3 is the final section of Module 5. Alright, so with that said, we have one learning goal for today, and that is you will be able to find and interpret the rate of change or slope of a situation. So for today, we're going to talk about how you determine the slope of a line from a graph, and then also how to determine the slope of a line when you're given 2 points. So we're going to use rise over run, and we're also going to use the slope formula today. So that's what we're going to look at, and then we'll wrap up with interpreting what slope means based off of the situation. Alright, so with that said, let's talk about some terminology and different information before we jump into our example today. Alright. For a function defined in terms of x and y, the rate of change over a part of the domain of a function is a ratio that compares the change in y to the change in x in that part of the domain. So rate of change equals change in y over change in x. So anytime that we're talking about a rate of change, we're talking about the change in y over the change in x. Now, the rate of change for a linear function can be calculated using the rise and run of a graph of the function. The rise is the difference in y values of 2 points in a line, and the run is the difference in x values in 2 points on a line. So the slope, which is where we're going to focus our attention on today, the slope of a line is the ratio of rise to run, or rise over run, for any 2 points on the line. Now, slope means the same thing as rate of change. So, rate of change equals slope, which equals change in y over change in x, which is rise over run, or difference in y over difference in x. So, our first example is we're going to go through and determine the slope of a line based off of a graph. Now, going based off of a graph, we need to think of this as rise over run. Okay, and that's what I talked about in this last part, is that slope equals rise over run. And that's what we're going to use for example 1. Alright, so example 1 wants us to determine the slope of each line. Now for part A, they give us a graph of a line right here, and they want us to determine the slope of it. Now they give us 2 points here and here as our reference point. If they don't ever give you 2 points to reference, one thing I want you to know is I highly suggest you use it where the grid lines match up, where their line crosses. That is going to help you be more accurate, because we're going to use the grid lines to count how much it is increased or decreased by. Alright, so now that I have my 2 points, to figure out slope is we want to figure out how much it's rose or decreased and how much it's gone right or left. So we want to go through and create a path going up and then down to get from this point to this point. So we're either going to go up or down, left or right. So that's what we're going to do. So I'm going to create a path going from that point to this point by going this way. So when you go through and create your path, okay, we can't cut corners. We just have to go up and then to the right, or down and to the left, whatever it may be. So this is my path, so I need to figure out how much this goes up by. So if I go through and count, it goes up by 1, 2, 3, 4, 5, 6. Now, because I went up, that is a positive direction. So it's going to be plus 6. If you ever go down, going down is considered a negative direction. Now, from here to get to this point, it's to the right 1, 2, 3, 4, 5. Now, going to the right is considered a positive direction. If we went to the left, that is considered negative. So I went up 6 and to the right 5. So for my slope, remember slope is rise over run. So how much did I rise by? Well, I went up by positive 6. And how much did I run by? I went to the right 5. So that means my slope is 6 over 5. Now, we're not going to worry about decimals on this. We're not going to worry about, compound fractions or proper fractions. An improper fraction is fine. It may ask you to simplify it if you can, but 6/5 is my slope for part A. So we're going to continue the same idea for each of these. If we look at part B, if I go through and create my path from these 2 points, I'm going to create a path like that. Now to get from this point to this point, let's figure out how much I went right, left, up, or down. So from here to here, I go over 1, 2. Because I went to the right, that's a positive 2. And then I go down from here to here, 1, 2, 3. Because I went down, that's considered a negative direction. So I went to the right 2, and then down 3. So if I'm writing my slope for this problem, remember, slope is rise over run, rise over run. So my rise is negative 3, because I went down 3. And then my run is going to be positive 2. So I have negative 3/2. Now, there is no simplifying involved because I do not have 2 negatives, and I can't simplify this further. So my slope is just negative 3/2. And that is how we go through and find slope between 2 points using rise over run based off of a graph. So again, you want to go through and draw your path, count how much you go up or down by, how much you go right or left by, create your fraction, see if you can simplify, and that is that. Again, going up or to the right is considered positive. Going left or down is considered a negative direction. Just something to keep in mind. So right or up is positive, left or down is negative. All right, so with that said, let's go ahead and take a look at parts C and D. And I want to take a look at C and D because they are a great example of something that I need to talk about. So for C, okay, my path is to these 2 points right there. Now I'm going up 1, so that's just considered a positive 1. And then I do not go right or left at all. So if we're thinking again, rise over run. Okay, I went up 1, but I didn't go to the right or left any. So that means it's going to be 1 over 0. Now, 1 over 0, and the reason why I'm talking about these is because something special happens. So if I were to, in my calculator, do 1 divided by 0, I get divide by 0 error, or your calculator may say syntax error or just error. You cannot divide by 0, okay? And that's something and why I just want to remind you. We cannot have 0 on the bottom part of a fraction. So because we have 0 on the bottom part of a fraction, that means that this is not my answer, but any time that you have 0 on the bottom, your slope is going to be undefined. So anytime you have a number over 0, your slope is undefined because I cannot have 0 on the bottom part. So know that anytime you see a vertical line, if you have a vertical line, your slope is always undefined. Now, if we look at D, a different situation arises. So I go from here to here, and all I do is go to the right 1, so plus 1. I don't go up or down at all. So if we're using rise over run, I don't go up or down at all, so that's going to be a 0. And I go to the right 1. That means my point is 1. So it's 0 over 1. If we take our calculator, if I do 0 divide by 1, oh, I got to get rid of that. If I do 0 divide by 1, I end up with 0. So that means my slope in this case is just 0. So you can write it as 0 if you want. Just if I box in as 0, it looks weird. So my slope in this case is 0. So know that anytime you have a horizontal line like this, your slope is 0. So I just wanted to talk about real quick while I have graphs here. Anytime you have 0 on the bottom, you have a vertical line, your slope is undefined. Anytime you have 0 on top, your slope is just 0. 0 on bottom, undefined. 0 on top, slope is 0. Okay, so that is example 1 in finding or determining the slope of a line from a graph. Now, on the back side for example 2, we're going to talk about how to find slope of 2 points or between 2 points based off the slope formula. All right. Let me move this around here. All right. Now, the slope formula for the slope of a line is the ratio of the difference in y values to the difference in x values. So rise over run, difference in y over difference in x. Now, the slope formula states if x1 and y1, or x1 comma y1, and x2 comma y2 are any 2 points on a line, the slope of a line is m equals y2 minus y1 over x2 minus x1. So we are going to use the slope formula. I would highly suggest that you have the slope formula written down somewhere that you can reference it. But again, our slope formula is m equals, m just stands for slope, y2 minus y1 over x2 minus x1. So we're going to get a fraction like we did on the front. Sometimes we can simplify that fraction to a whole number. Sometimes we just have to leave it as a fraction. So using the slope formula, we are going to go through and answer our questions for example 2. Now, example 2 states, find the slope of each line passing through the given points using the slope formula. So, for example 2a, I have points 12, comma, negative 7, and 2, comma, negative 2. So I need to find the slope between these 2 points. Now, my suggestion, what I suggest you do first, is go through and identify what your x1, y1, and your x2, y2, just like here, for these 2 points, because it will help you when you plug it back in. So x1, y1, x2, y2. So I'm going to go ahead and move this up, just that way we can focus on this problem. And then I'm going to bring in the slope formula to reference. So our slope formula is m equals y2 minus y1 over x2 minus x1. So if we go through and set this up, we're going to have m equals, So it's y2 minus y1. y2 is negative 2. y1 is negative 7. So this is going to be negative 2 minus a negative 7 over x2 minus x1. So it's going to be 2 minus 12. All right, so I have negative 7 minus, negative 2 minus a negative 7 over 2 minus 12. Now, for these problems, you want to do the top and then do the bottom. So we're going to do negative 2 minus a negative 7, and I get 5. And then if I do 2 minus 12, I end up with negative 10. So if I have 5 over negative 10, we first need to ask ourselves if I can simplify this. So can you simplify 5 over 10? If I take, so I have to do negative 5 over 10, and that did not work, sorry. Negative 5 over 10, there we go. I end up with negative 1/2. So that means this 5 over negative 10 simplifies over to negative 1/2. And that is my slope for part A. So my slope between my two points is negative 1/2. It means I go down 1 to the right 2, down 1 to the right 2 to get to these 2 points. All right, let's continue on. For part B, and just kind of leave that there for you. For part B, we have the points negative 5, 6, and 8, 6. Again, your first step is to go through and identify what your x1, y1, and your x2, y2 are. So this is my x1, y1, and then my x2, y2. So now that I've identified my x1, y1, x2, y2, like I've done here, we're going to go through and plug it into the slope formula. So my slope, m, equals y2 minus y1, so y2 minus y1, so I get 6 minus 6, over x2 minus x1, so that's going to be 8 minus negative 5. So 8 minus a negative 5. So that's going to be plugging everything into the slope formula. I now just need to go through and calculate. So if I do 6 minus 6, we get 0. And if I do 8 minus a negative 5, we get 13. So I have 0 over 13. Can I simplify this? If I do 0 over 13, I end up with 0. So that means 0 is my slope. So the slope between my 2 points is 0. All right, and that is how we're going to run through and do part or example 2. Now, I do want to take a look at parts C and D real quick, just to kind of give you a reference of how other ones are done. If we look at part C, so I have negative 4, comma, negative 17, and negative 4, comma, negative 3. So my x1, y1, and my x2, y2 are like such. We're going to go through and use my slope formula. So m equals y2 minus y1 over x2 minus x1. So m equals y2 minus y1, so negative 3 minus the negative 17, over x2 minus x1, so it's going to be negative 4 minus a negative 4. All right, so now we need to go through and do our simplifying on top and then simplify on the bottom, and then see if we can simplify our fraction from there. Now, one thing I haven't talked about, but just to highlight, remember anytime you have minus a negative, that turns it into positive, so adding. Again, minus a negative makes it addition. So if you don't have a negative button, or you're struggling with that, just know that minus a negative results in addition. So we're going to have negative 3 plus 17. We end up with 14. And then if we do negative 4 plus 4, we get 0. So we have 14 over 0. And if we do 14 over 0 on our calculator, we get our error message, because remember, anytime 0 is on the bottom part of our fraction, that means that it's an error. So our slope is undefined. And that is how you do part C. Now, I do want to run through D real quick, just to give you more problems to reference and more things to see. So for part D, first we're going to identify our x1, y1, and then our x2, y2. So again, we're going to go through and use our slope formula. So y2 minus y1 over x2 minus x1. So we're going to do negative 1 minus a negative 10. So m equals negative 1 minus a negative 10 over x2 minus x1. So negative 1 minus negative 3. Okay, so if I do negative 1 minus a negative 10, I end up with 9. And if I do negative 1 minus a negative 3, I end up with 2. So I have 9 over 2. If I go through and check to simplify, so 9 over 2. So that's going to take me to 4 1/2. I don't really want to deal with compound fractions. Okay, I just want to deal with improper fractions, or just one whole fraction. So if I checked this, okay, it just stays as 9/2, so this doesn't simplify. In case it would want to know the decimal, you would just do 9 divided by 2, and that would be 4.5. So it could be 9/2, and it would also be the same thing as saying 4.5. So in case it wants a decimal, know that you would just do 9 divided by 2 to get your decimal. If it's okay with the fraction, leave it as the fraction. Odds are it wants you to leave it as a fraction, so 9/2 would be your solution. All right, so we have talked about how to find slope from a graph using rise over run. We have now talked about how to find slope when you're given 2 points using the slope formula. Now, last thing that I want to talk about, example 3 is going to ask us to find and interpret the slope for each real-world situation. So, for example 3, for A, it wants you to find the slope from the graph, and B, it wants you to find the slope from the points. Now, I would suggest you go through and use the slope formula. So you do your y2 minus y1 over x2 minus x1. So if we looked at that for A, if I define this as my x1, y1, and then my x2, y2, remember the slope formula is y2 minus y1 over x2 minus x1. So using my slope formula, we're going to go through and figure out our slope. So it's y2. So it's going to be 150 minus 180 over 50 minus 20. So I've done y2 minus y1 over x2 minus x1. If I do 150 minus 180, I get negative 30. And if I do 50 minus 20, I get 30. So I now have negative 30 over 30. And if I go through and simplify this, if I do negative 30 over 30, I end up with negative 1. So my slope for this problem is negative 1. Now, for example 3, it wanted me to go through and find and interpret the slope for each situation. So I found the slope. I now just have to go through and interpret what negative 1 means for this situation. So what it means is that for every year, so we're going to consider like the x values first, for every year a person's for every year a person's age increases, their heart rate decreases by 1. So let me write this out and I'll re-explain it. So for every 1 year, a person's heart rate, for every 1 year, a person's age increases. So every year that their age increases, as we go right to left, their heart rate is going to decrease by 1 BPM. Again, for every year person increases in age, their heart rate decreases by 1 BPM. All right, and then if we looked at B, you would just run through the same thing. So they give you 2 points. So you would identify your x1, y1, your x2, y2. You would use your slope formula like such. So we would end up doing 4,000 minus 3,000 over 60 minus 40. So we would get 1,000 over 20, which would give us 50. So the water is increasing 50 cubic feet per hour based off what they're saying here, because they're talking about the number of cubic feet in water in a reservoir hours after the water starts flowing. So the water is increasing 50 cubic feet per hour. All right, so that is it for section 5.3 on interpreting rate of change in slope. So we've gone through and determined a line's slope from the graph. We've also talked about finding the slope of a line when you're given 2 points. And then we just went through and talked about how to find and interpret the slope for a real world situation. So with that said, that is it for today for section 5.3. And remember that section 5.3 is the last section of module 5, meaning there's a quiz upcoming soon. So that is it for today, and that's it for our lesson. If you have any questions, as always, you can reach out and either shoot me an email or let me know next time you see me. But otherwise, that's it for today. Thank you guys for listening. As always, be sure to use the completed notes as a reference as you go through the homework. Let me know if you need any help. But that is all for today. I will talk to you guys later, and have a great day. Bye.